Hi, you're watching Port 25. I'm Sam Ramsey, Director of the Open Source Software Lab at Microsoft. In my office today, I have Dr. Wayne Citrin. He's the CTO of JNBridge Corporation. Wayne, thanks for taking the time to be here.
Thanks, Sam.
So before we get dug in too deep on JNBridge, which is what we really want to talk about, tell me a little bit about how you got started in technology.
Okay, well, I guess I've always been interested in technology. Computing, I think it really went back to high school and programmable Wang calculators, of all things.
No way.
Yeah, you remember those?
No, I think that even predates me.
Oh, okay.
I was on the Trash 80s and ZX.
Oh, yeah, this was a few years before that.
Yeah.
You know, they had like Mark Sense cards, so you could like program by filling in stuff with pencils.
That
And
is cool.
yeah, we learned how to hack those. It was kind of fun. A few years after I left, they got their first computer terminals. But so no, I've been interested in solving problems like that all the way, through college. I majored in computer science, got into grad school, and got into compilers. I thought compilers were the coolest thing, and that kind of led to the sort of stuff that we're doing. I eventually ended up at University of Colorado. Left and did a bunch of, got involved in a bunch of startups, but...
You did some really interesting things in the 90s.
Oh, okay, we'll go back there, yeah. So I was at IBM's research lab, and, at the end of the 80s, doing some visual programming sort of stuff. Mm-hmm. And, the idea was specifying network protocols visually using notation. It was kind of like very early domain-specific language sort of things. And we had some nice little demonstrations, which I think got used at some point. This is the IBM's research division in Zürich, so I actually got to see Switzerland.
What's old is new again. Have you heard of Puppet?
No, I have not heard of Puppet.
It's a domain-specific language built by a guy named Luke Kientz to describe Unix networks.
Interesting. Okay, yeah. I mean, I've been out of that for a long time, so it's interesting that sort of thing is being picked up again. I think
it's always the case in computer science.
I know
it. Things we just recycle them from the 60s.
I know it's great. It really is, and it's always surprising when you see it. So yeah, I was involved in that and worked on that for a while in other various visual languages fairly early on. Got into right after when I left the university, we were working on essentially 3D visualizations of websites, and that was pretty cool using the cone trees that Xerox PARC created to kind of fit a lot of stuff in. And so the idea was being able to go and spider a website remotely, get the whole structure and visualize it. And then the tool that we were developing would analyze the log files, project those paths onto this 3D thing that you could manipulate in real time, and analyze usability problems. There were like half a dozen usability problems, like pogo sticking and going around in circles. This was really pretty early on in the web analysis stuff.
It's almost like a code coverage tool.
Exactly. Did people see things? Did people do things in weird ways? Were people finding what they wanted?
Interesting.
So that was the sort of stuff that we were doing, and that it was a company called Lumio. Eventually, went on to become part of other products. At some point, though, I was looking at what to do next, and we were looking at a friend of mine at the university had just come back. This was in probably around 2000, 2001. Just come back from an academic summit here in Redmond and said, you want to check out this .NET stuff. So I started looking at that. Another friend of mine who realized I was learning a little bit about .NET asked me, can I use my EJBs with .NET? And I said, well, I don't know. Let me check this out. So started thinking about it, started looking at actually news groups, Usenet news groups, where people were asking, what's this .NET? Can I use my Java with it? And I think that was kind of like a focus group almost. It's like, yeah, there's going to be a demand for this. So we went in and we started building our product, and I think that some people got it right away. Other people kind of said, well, what do you need this for? I got Java. Why do I want to talk to .NET or vice versa? But I think in a couple of years, I think everybody realized that these things don't stand alone. And we've had a lot of encouragement from folks at Microsoft, but also other companies too. They kind of know that this is an important way of doing things.
Yeah, when I was at BEA, right around the same time, 2002 onwards, that was often a challenge, especially in large banking customers. How do I connect my .NET or Microsoft-based front ends to my Java backends, and how does all this stuff work?
Exactly.
Obviously, there's a ton of investment in WS Star these days, all around the industry, and web services connectivity. But JNBridge does something really fundamentally different than a web services, XML, loosely coupled, asynchronous messaging type of bridge.
That's correct.
Why don't you tell us a little bit about what JNBridge actually does, and then probably a lot of this will be more obviously whiteboarded down.
Sure. Well, the issue with maybe we'll start with the whiteboarding, because I think that's a good idea. Web services are really useful, as a standards-based approach. You can look at you can really access a lot of stuff if you've agreed on with standards, but there's some problems in a lot of cases with web services. There's it's XML based, so it's slow in some cases. When you're passing these big XML documents around, you have a service is really just a you can think of it just a hole into a component, and it's really a fairly narrow hole, and that's actually in some ways a good thing, because you've got a well-defined interface, and everything in that can change, but the service stays the same, and it's easy to discover the service and its particulars. But there are times when you want the entire object-oriented API. Rather than a service, you want to access hundreds of classes. This is not for your loosely coupled thing where things are distributed all over the place. This is for a more tightly coupled scenario where, let's say, you have some legacy Java product, or just a component you've built that you can't migrate, you don't want to migrate, it's working fine. It's an API, and you want to access it from your .NET. We also have people going the other way. As .NET becomes more mature, there's legacy .NET that they want to interoperate with. But the idea is, instead of one service, you've got lots of classes, and you want to really get into it. This really makes sense more for the tightly coupled approach. And in fact, with the loosely coupled approach, you got to handle things where this guy goes down, you got to start him up again, you have to worry about state. And the tightly coupled approach that we have, that's not really a concern. It's understood that these are really almost local development and part of the same project almost.
One of the early problems I remember with people's understanding of web services, but actually ended up being something that was a really common use case, was I have this .NET front end and I wanted to work with this Java backend. So in this case, what I saw people doing was they were trying to build a web services, an XML front end, where they said, well, we're just going to pass all these objects as references in XML.
Yeah.
Well, that doesn't work.
That's right.
Unless you want to serialize the entire object graph and get it out there, you're in really bad shape. But this ends up starting to solve some of those issues, because you can actually, if I recall correctly, get Java objects look like .NET objects look like Java, and vice versa.
You're absolutely right.
So why don't you walk us through that a little bit?
Okay. Well, what you have here, that's an excellent point. What we have here is you have your Java code, and you may have a bunch of classes or objects. A bunch of classes, a bunch of objects from those classes. And what we do is we take a proxy-based approach. So what we have is a tool that will go in. You can either say, look at all the classes in these jar files, or you can say, I'm interested in particular classes to access. And it will go in and reflect on those and create on the .NET side a bunch of proxies for those classes.
It's .NET code that looks like .NET native classes.
Exactly.
You're not thinking I'm talking to a proxy.
Exactly. So if you have a Java class, x.y.z, you'll have a .NET class with exactly the same name. And what we do is, rather than generate source code, we save you the trouble and actually spit out real .NET binaries using the reflection emit facility in .NET. And so we have a whole. It's a DLL. It's a class library, .NET class library, DLL, and assembly, and you just link this in with your product, with your project, and you access. If you want to access a Java class, you access the proxy of the same. You don't know it's a proxy. You think it was written in .NET. If you want to call a method, you call the method on that proxy class. You want to instantiate a Java object, you instantiate the proxy, and so on. And as you said, you can call anything Java from .NET. So if you want to get a field, if you want to get a method, it all works. And so what we do here is we have a bunch of runtime components on the .NET side and on the Java side that the proxies essentially know how to communicate through them, and then come back and and then unmarshal the result. Now, this is one of the nice things about what what you're saying that we do that the web services doesn't do, is that we can actually pass references back and forth. So you don't need the whole object. You don't need to serialize the whole object. A reference is really small.
Right.
It's just maybe the name of the class, an index into a table, and maybe a pointer of the machine that happens to be on.
Right, so it's much more efficient on both sides, both for the interpretation for the passing.
Exactly. No, the downside, of course, is that each time you want to access a member of that method, it's a round trip. But that's often not so bad. If you want to be local all the time, you can actually serialize the whole thing and send it across. So we have ways to pass by value. Now,
so what I hear is cross-platform inter-process communication. Right. Cross-platform meaning cross-language or cross-component model, really.
Yeah, exactly.
What are some of the deployment models that you could have here? Right. Because it seems like this would be something that I might shy away from if I were doing this on two fairly remote servers. That's a topology I'd want to see web servers in. So show me some of the advantages here.
Okay. Well, one of the advantages is that we build this communications mechanism on top of .NET Remoting, which is a pluggable architecture. There are all sorts of communications mechanisms you can put in there.
So you can plug it into TCP, you can plug it into all sorts of other lower layer comms.
That's exactly right. So what we have here is we offer three different channels. We have an HTTP SOAP channel, and it gets you about web services performance, but you get the whole object-oriented API, and you get callbacks and exceptions and pass by reference and the whole bit. So that's there. We have a TCP binary channel, which is about over 10 times faster than the SOAP channel. And here you can put stuff out across your network. If you have, you can also use this across like through firewalls and stuff like that, the SOAP channel. Though most people like to use the TCP binary channel. One of the things that people like to do, which is very popular, is we also have what we call a shared memory channel. And this is really cool. A lot of people think this is very cool. What you have in the other cases, these things are running in different processes which could be on different machines, across the network, communicating with sockets. If you want, with shared memory, you can take the .NET CLR and the JVM and put them in the same process. Essentially host them both in the same process and communicate not through sockets but through just shared memory structures. Just take something and pass it down the stack and hand it off to the Java class.
So I've spent a lot of time in the Java distributed computing space. I've never seen anything else like this. Am I just ignorant? Is there something else out there that takes a similar approach?
Well, basically it uses JNI. Yep. So there aren't a lot of things that use the same approach. There are a couple of other products out there that actually will essentially do JNI wrappers.
Shared memory and having .NET and Java execute the same process.
Yeah, there is a couple of stuff like that. But yeah, it's really cool. Most people just don't know what can be done.
But this can solve a lot of architectural problems where you're trying to get .NET to write to Java message-driven backends, right? Where you've got a JNX interface to some sort of durable messaging pipe, whether that's TIB or something else. And now you've got a .NET front end of that.
That's right. What we can do here is take the Java classes that we proxy and put into this. Could be like JMS client classes, or even, which is really cool, they could be the JMS interface classes, so that you can create a vendor-independent adapter between .NET and JMS. Because what we have here is the ability, when the Java side hands back a new unknown class, we can create the proxy on the fly and keep it in like transient memory and use it, through the execution. And so when if one JMS provider creates one flavor of a message factory or a queue object, and then creates another one, another vendor creates another one, we can handle that with the same thing as long as we just change some parameters. So, for example, we have lots of customers using this for JMS connections.
Sure.
We have customers using it. We've actually created some guidance on how to build BizTalk server adapters that'll talk to that'll talk to JMS.
Interesting. It'll be interesting to see if you get demand for WCF adapters on the Java side. Java people wanting to use this to connect into WCF.
I think we will. People have already started mentioning it, and we've been looking into that. I think that'll be really cool when we actually offer that.
This is a neat variant. I can happily fill up another 45 minutes of conversation here, but we're out of time,
Sure.
so we need to go. But what I'm going to do is invite you to participate on the comments on the forum when we post the video, and hopefully you'll get some fairly meaty conversations there.
Likely. Excellent.
Love to have you back again.
Well, thanks a lot, Sam.
Cool. Wayne, thank you so much for your time.
Thank you.
All right, so Wayne doing some rocket science between Java and .NET, and hopefully you found this interesting, informative. Wayne will certainly be around for comments. As an old Java hack, I will certainly be watching the comments forum myself. So take care. Thanks for watching Port 25. We'll see you next time.